work as a bridge to Fabio, and we are all here tonight. I guess that there is a great curiosity and great interest in the topic, and it's great to be all here connected with the same spirit of being interested in pure innovation, and it's a great pleasure to do it with distinguished friends, new friends, and colleagues. So the microphone goes to Neil to introduce the topics and the panelists.
Thank you. Thank you, Arturo.
Grazie.
So, but can I just maybe just repeat to Fabio, who's over there in the UK? Thank you. Grazie mille, Fabio. This is a very special event from a Digital Futures point of view, in the sense that we've never hosted a hybrid session before. This has been live streamed through Digital Futures, and there'll be recording afterwards. It will be uploaded onto our YouTube channel. It's also a first in the sense of the first time we've ever been part of the Venice Biennale. And I've got to say that it makes more and more sense to think about this in the future, because everyone parachutes into to Venice for this event. And it's extraordinary how this thing has snowballed in some senses. From the very beginning, we had our list of individuals, fantastic list. Then Chantal was going to be here, and Sara Codarin is going to be here, and all of a sudden we have our surprise guest of this evening, Ross Lovegrove, who's someone who is the most extraordinary industrial designer, and he literally, I'm not sure parachute is the right word because his flight was delayed, but anyway, he's here with us today, which is extraordinary, and it's a most amazing event. I think the word that you use, bridges, I think a really important one. I think that Venice is a city of bridges, overcoming divides, and this is really what we try and do in Digital Futures, to overcome divides, and not just physical divides. What we try and do with our platform, we try to break through the physical walls of the classroom, first of all, but also the socioeconomic and political barriers that prevent people from having access to education. So this has been live streamed, and there'll be people, I can tell you, there'll be people in Baghdad, there'll be people in Bangladesh listening to this. It's a wonderful opportunity. Anyway, thank you also to Arturo for also being the kind of catalyst in this extraordinary thing. It's an amazing moment right now we're living through, an extraordinary moment, both in terms of architecture, I think as society as a whole. It's also, I would say, a slightly terrifying moment, because those of us who've been working on AI for a while are quite astonished by how effective some of these tools are, especially the GPT logic and so on. So it's an amazing thing, and it's transforming architecture. Today, we're actually bringing together some individuals who've been working in different backgrounds before AI. And we're kind of looking at the basis of how AI begins to emerge out of the world, let's say, of Grasshopper or of Swarm Intelligence, out of other softwares we've been using. And then looking towards the future. I'm delighted that we have Wanyu here today. A few days ago, Wanyu He launched her latest AI software package for Xcool. And today I found out that they're going to be actually offering this software in the West. She used to work for OMA, and of course, AMO is the opposite way around. They've taken the word Xcool, and it becomes Looks, L-O-O-K-X. That's going to be the Western version of it. So it's a very, very special moment. So anyway, here we are also in this amazing Aula Tafuri. I mean, Arturo Tedeschi is somebody whose reputation goes way beyond Venice. Everyone around the world knows about him as a kind of critical theoretical figure. We had a session on him recently. It's a great honor to be in a place like this institute, one of the most famous schools of architecture of all time, especially in a room that is dedicated to Tafuri. So I've already said this, basically, what impact will AI have on the future of architecture? And hopefully you're going to get a selection of viewpoints that are going to point towards things in the future. Let me start, though, by just saying a very few words about our guests. Most of our guests are so famous they need no introduction, but I will start with Roland. And Roland is somebody who we don't see in Europe so often. Roland was teaching in the States for a while in both East Coast and West Coast. He's now returned back to Australia, where he's a professor at RMIT and producing some astonishing work. Roland and I some years ago produced a book on swarm intelligence, and we're both kind of obviously looking at AI more recently. Wanyu, again, a surprise to have her here today. And Wanyu is used to work for OMA, for Rem Koolhaas. Her practice Xcool is named after that, Xcool, and she is now the CEO of the leading software developer, I think, in the world, the leading AI software developer for architecture in the world. Nicolo Casas is not physically with us today because he lives in Emilia-Romagna, and those of you from Italy know that Emilia-Romagna is underwater, as indeed his particular house is. So he will be zooming in and joining us on Zoom. Then Chantal Matar is somebody you probably also know. Chantal has been working for Zahidid Architects for some time, has now set off on her own, and she has the most exquisite oeuvre of work exploring possibilities in computation. Tim Fu also used to work for Zahidid Architects. He's part, he does work for Zahidid Architects as part of ZHA Code. And Tim will be joining us later. Sara Codarin from Italy, from the northeast of Italy. Sara is now a professor in the States at, I'm trying to remember the name of the place now, Lawrence Technology University. And she combines a wonderful interest in the history of architecture with robotics and so on. Arturo needs no introduction. He's a rock star here in Italy. He's also known all over the world. They also, I think, worked for a while for Zaha. There's a connection all between this, but Arturo has been, setting the world alight, especially the world of Instagram alight with his designs. And I'm going to finally bring up the rear, as it were. But I'm going to say something to start things off by way of introduction, because I think a lot of people, we've all been kind of catapulted into a world where we talk about AI, and not so many people actually know what AI is. Most people think it's something to do with Midjourney or DALL-E. So I wanted to say just a few words about this to those of you who don't know anything about this, and apologies to all those who do. The term AI was actually coined in 1956 by this guy here, John McCarthy. He wasn't very happy with the term, but he thought, we've got to call it something. Personally, I don't think that's a very good term. I don't think it's artificial at all. It's synthetic, perhaps. And the term intelligence tends to anthropomorphize it. I think really what we're talking about is really, in my word anyway, I mean, I follow the work of Claude Shannon, one of the early kind of informational theorists who thinks we're dealing with information. It's a processing of information. Anyway, we have the term AI, for better or for worse. It was in 1956, they had a gathering of all the kind of the smartest and the brightest in the States to try and see if they could solve the problems of AI in 2 years. Well, they didn't manage to do that. And actually, to be honest, when they met again, these are the survivors in 2006. And by 2006, frankly, they hadn't achieved anywhere near what they expected to do. In some senses, AI had not lived up to the hype. So what exactly is AI? And it's not so easy to come up with a definition, but let me just take this one from Margaret Bowden, who is the kind of grand old lady who's of cognitive science, who's been working on for some time. AI seeks to make computers do the sorts of things that minds can do. Well, this is still correct. In some senses, it's not. First of all, because in certain particular domains, AI is far superior to human beings. No one can ever think of beating AI at chess or Go anymore. It's in those areas, forget it. It's clearly much better. And secondly, do the computers really need to do all the things that minds can do? I'm not sure that computers need to be conscious. I don't even think AI needs to be conscious anyway. But nonetheless, what this quote is kind of interesting about it is the way that it does connect it to the mind. And I think that what we have now is a world of neural networks, which actually are based very loosely on the mind itself. But this is a neuron, and these are connected by synapses, and they have many layers of deep learning. And the information is processed from left to right, governed by the weights on the synapses, and so on and so on and so on. It's loosely based on the brain, but the important thing is that AI doesn't have consciousness. It is not self-aware. It might be thrashing us at Go or chess. It doesn't even know that it's playing chess or Go. It has no more capacity to think than a pocket calculator. And that's part of my reason why I'm nervous about the term intelligence. If you can't think, how can you be intelligent? If you can't think, how can you learn ... But anyway, this is the important thing about this is that by 2006, they hadn't achieved very much, but 2006 was roughly the time that these neural networks took over and the deep learning revolution happened. Now, deep learning could be understood as a kind of subset of machine learning, which is itself a subset of AI. And really what we're talking about these days, especially in terms of GPT and so on, is deep learning. This is the most advanced, most successful thing that really has realized this astonishing potential. And so what about architecture? Let me just briefly give some background to how this is used. Some of you might have noticed the different debates going on recently, one about whether or not we should slow down exploration into these large language models, a letter signed by Elon Musk. I don't think that's going to work. It's a bit like asking the two leaders in the Olympic marathon to slow down. They're not going to do that because the others will catch up. The other person who you might have noticed as well is Geoffrey Hinton. Geoffrey Hinton, I wouldn't say he's the godfather of AI, but he is the godfather of deep learning. And he is nervous about some things about AI, and rightly so too. But Geoffrey Hinton is the real hero behind deep learning, because when it was out of favor, he was pushing it and pushing it and pushing it. He was convinced that if we reached AI, it would have to be, we have to think about how the brain itself operates and model it on that. And it was around 2012. So I mentioned 2006 was the beginning of the deep learning revolution. Well, 2012, Geoffrey Hinton's team managed to win a competition to recognizing an image. Now, we think this is these days it's obvious, right? We all have facial recognition on our phones and things, but in 2012, this was really novel. In fact, you could take an image of a bird and process the pixels through these different layers and arrive with the idea that it was a bird. Now, that was amazing. But the holy grail for computer scientists was to work the other way. In other words, how could you hallucinate an image based on a word? That was the crucial thing. And what they discovered, there was a guy working for Google called Alex Morvinsev, who discovered that if you work the other way, you could actually generate something. And this led to what led to what we know now as Deep Dream, this somewhat trippy image you could see a neural network here trained, I think, on dogs or serpents or something. It's like an oil lamp or something, has hallucinated this image. Now, it's trippy because the information about where things should be has been lost in this process, but nonetheless, this was astonishing. And the first ever exhibition on AI-generated art happened in 2018 based on this. But then something else happened, the invention of generative adversarial networks, and this was really a huge step forward. Here you had two neural networks, a generator and a discriminator, competing against each other. The generator would take random noise and generate an image, and then the discriminator would judge this against a random training set and decide whether it was good or not, and in the process would train the generator. And then this led to this kind of thing that was clearly astonishing compared to everything else. The use of style GANs, there's a whole range of these different GANs. And this was really a kind of a watershed moment when we could do this, when we could hallucinate images. Now, none of these people exist. And there is actually a site you can go to called This Person Does Not Exist. When you also had a site, this building does not exist for a while. And every time you refresh your browser, you get a very convincing image. It wasn't long before architects began to sort of to play around with these things. Actually, the first person I would say wasn't an architect; it was a media artist, Refik Anadol, who is the rock star, I'd say, of AI media art right now. And in 2019, he took the work of Zaha Hadid Architects and he inputted it and he hallucinated for the first time something we've been talking about but hadn't done. A design of a building that was generated by AI. In 2019, actually, for the Venice Biennale, I submitted a proposal with Zaha Hadid Architects and sponsored by Google and with Refik to do the British Pavilion based on an AI, and we weren't even shortlisted. It was that bad. But things have gone a long way from 2019 to 2023, and in the space of 4 years, AI has really hit the scene. But what you'll see from this, from the basis of this style GANs has been used to hallucinate an image of a design. that could have been designed by Zaha, but wasn't, interpolated based on this data set, and eventually literally coming out of the computer, we get, I think, what was the first GAN-based design by Refik Anadol, which was the image that I used in the front cover of my book that is about to come out in China and Chinese and a few other languages. And then we moved on to something else. This is the work of Roland Snooks for Core Himmelblau, Deep Himmelblau, where he's using cycle GANs. And this is a more sophisticated technique. They're two unpaired data sets, and you effectively extrapolate. You're breeding things rather than being limited by simply interpolating. And in 2021, I would say this was the state of the art. This was something that was really quite cutting edge. And this project itself won a number of awards. It won an Acadia Award. It won a Digital Futures Award. And it was really the best that we could do at the time. You can see in these images, it's not bad. It's based on the 1,000 or so projects they've had in Core Himmelblau, and it's hallucinating other possible designs. Slightly glitchy, everything is slightly glitchy. This GAN technique is extremely laborious to do, to upload the images. It takes a long time to train them and so on, and the images aren't so great and so on. But nonetheless, this was the state of the art in 2021, not bad in some senses. We could see those possibilities, and this was then used. We used this on the cover of the AD, Machine Hallucinations, Architecture and Artificial Intelligence, which was, I think, the third book that came out on AI and architecture. But then this time last year, something extraordinary happened. I was giving a lecture at the AA, and nobody really kind of picked up on AI, just that they hadn't been totally convinced because the images were not quite good enough. But around that time, they launched DALL-E. Now, DALL-E is produced by OpenAI, the same people who produced ChatGPT and GPT Logic and so on. This is the real revolution that's taken place in the last few years. And what you do with this is a very different process. You write a prompt, and we all become prompt engineers, and we've got to be very precise about how we write this prompt. But what startled people very early on was this simple prompt: an astronaut on a horse. Now, the point being, I presume no astronaut had gone for a ride on a horse before. It didn't matter. What it's doing, it is not copying anything. It's searching and synthesizing material, and it's effectively showing you what an astronaut would look like on a horse if an astronaut had been on a horse. This was really quite striking, and the quality of the image was something entirely different. This is what we know as diffusion models. They're very different to GANs. They operate, they're a pre-trained model, massive pre-trained models. And you can do this relatively quickly. You haven't got to train the model yourself. You can do it relatively quickly. And the quality of it and the kind of the rendering techniques and so on is really superior. And it takes like 2 minutes or something. It's astonishingly quick. And what happened is basically that Refik had been collaborating with Zaha Hadid Architects, and this was the next generation of images being generated through these diffusion platforms, and much better than the earlier ones. And all of a sudden, even though these are 2D, you get a strong sense of three-dimensionality. You have a strong sense of textures and materials and so on. And it wasn't long, of course, before Midjourney was launched, and everyone could do this. And this is just the work that I did, but kind of somehow also inspired by Zaha. And literally, the whole world became democratized. Everyone started posting these on Instagram. Anyone is on Instagram, and that's the place where you find out about it. And really what was astonishing about this is not only because you don't need any technical expertise, but the quality of the images, the rendering and so on, and indeed the resolution of the image is far superior. And what it was doing was coming up with solutions that none of us would have thought about. It was just generating, breeding possibilities that we wouldn't have imagined ourselves. And over time, these models got more and more refined in different generations of these things until they got far more convincing in terms of their materiality and so on. So anyway, this is just the stuff that I was producing a while back. But everyone's producing this now. And I think if you go on Instagram, you'll find people just generating a project every night, or maybe several projects every night. It's just astonishing the way that it's just kind of opens up these possibilities. And of course, firms like Zaha Hadid Architects are using these to kind of to brainstorm ideas in entering competitions and so on. And there's something truly astonishing. This is the work of David Orff, who's publishing his stuff on the whole time. This is a winery that he did. And then there's Carlos Bannon, who's been on Digital Futures giving tutorials and things. He's a Spanish architect teaching in Singapore. And there was an exhibition about this recently in Texas, Architecture After AI. I'm not sure there's going to be an after AI. I don't think AI is going to go away. But what I would say is, in some senses, a slight trap if we just stuck with the world of images. And what I would also say is that actually those who are really pushing the boundaries, and it would have been lovely to have have Daniel Bolojan here today. Wolf Pricks is in town, but not Daniel Bolojan, because Daniel has really been taking things to another level. Instead of training these models on just images, he's training them on parameters. And what he's effectively doing is getting a scenario whereby you can relate the interior of a design to the exterior, the east, the west, the north, the south elevations can all kind of relate to one another. And I think by customizing it and training it very deliberately on the work of the office, they're coming up with something really quite astonishing. There is, alongside that, I'd say, also the commercial world of firms like Spacemaker, and of course Wanyu is with us today, Xcool, where they are developing software which in about 3 years' time will come on stream. Some of it already is on stream, and we'll see today from Wanyu, but that will really transform architecture. That will create a single platform whereby we go from data to fabrication, where we don't have all these discrete sort of processes where we have sort of Mid-Journey followed by Maya, followed by Rhino, followed by BIM, but rather one continuous platform. And I think this is going to be the real kind of game changer. And alongside that, we'll find out more, I think, from Wanyu. I think the world of GPT is also going to fit in an astonishing way to surprise us in a way we had never imagined. I'm going to leave it there with that as a setting the scene for the presentation today. We have a kind of a Pecha Kucha style presentation today, and I would like to call upon Chantal to come and do the next presentation. So welcome, Chantal. Welcome.
Thank you, Neil, and thank you, Arturo, for the invite and for being here, and for everybody who joined us today. For me, it's going to be a very personal journey with AI. Just in the presentation. Oh, there it is. Yep. Okay. Well, to start off, as Neil was mentioning, I used to work at Zaha. I'm an architect and I'm also a generative artist. And in my little practice, I've been doing a lot of different things, mainly art exhibitions and a lot of architecture competitions. And recently with the whole AI revolution, I've been quite immersed into machine learning and getting AI and how to merge it with architecture and how to basically solve some issues, etc. So first thing first, I wanted to include this specific scene from The Matrix that we all know. It's the scene where Neo meets the architect. And in that scenario, machines defeat humans. So it's a bit of a grim future. And the machines write architect program, and the architect program writes the matrix. So basically, this in one scenario in sci-fi is our future. I wanted to include that because there's a lot of speculation about AI. There's a lot of negative views to start with people who are working with AI. And the only reason why we do that is because there's a certain fear, and that inspired the specific sci-fi blockbusters, etc. And that fear stems from the fact that machines in the future are sentient beings, which is not the case yet. So I just wanted to start off with this negative point to go into the positives. Starting off with creativity and natural language. And the way I use AI, and in the last year, I started to immerse myself into it. I like to compare it to Jackson Pollock painting. That this is just reflecting the pure prompt engineering process. And the fact that whatever you describe, you unlock a lot of imagination, and your words are your design tool in that case. So that was the first step into working with AI. And the reason why I wanted to include Jackson Pollock is because his paintings, in a way, just stemming from art point of view, is basically just purely founded on his expression. So whatever he feels, he wanted to paint. Similar thing that we do when we want to prompt, whatever we imagine, whatever we want to describe, you actually do it in words in this case. And going on from that point of view, these are some interiors I was exploring with using prompt engineering purely. There were no third party introduced. It was mainly fractal interiors. I wanted to experiment a bit about these visuals and to what extent I can create interesting natural elements flooded with the design process. And some other also inspirational images to start from. These are some emotive interiors. There's also this notion using AI that you can create emotions in a way which is something that you weren't able to do using standard tools. So that was one of the elements that is quite powerful using this tool. This is specifically Midjourney though. I use other platforms, but I found Midjourney quite flexible in terms of creativity and abstract thinking in a way. This is another sort of interiors I experimented with too, from the kintsugi elements. It's also a Japanese art of repairing broken pottery with gold ceilings. So I like this notion of this concept, and I wanted to replicate it into an interior space. And I was able to do that quite quickly at the same time, just to experiment the spaces and have a bit of dialogue out of these specific interiors. So that was one. Now we're going into control. As I was mentioning about the matrix, there's always this notion of control and choice. So these are the main theme of the movie. And similar now that we're using AI, we want to have some form of control. We're always in dialogue and trying to express our fears or our interest into how we can create this type of control. And stemming from, this is one of my earlier work in acrylic paintings, I wanted to include the specific art piece into a 3D interior space. And using Midjourney specifically, I was able to include this into some of the interior spaces. And this is one of the cells organization that I was able to do in acrylic, but I was able also to do them as a 3D space. Moving on from that, there's also the interscalar process of the specific art piece. I was also able to replicate it into an urban scale, which is quite interesting to see using AI. There's also this specific piece as well. So the one to the right, to the far right, is a 3D model I did using Houdini. It's also a representation of mineral formation. And also, I was able to replicate it in terms of interior mineral geological formation with furniture. It's quite a surreal, abstract concept, but it's also interesting to see in 3D space. And now we move on to the third part, which is evolving furthermore than just a 2D image. So now we're going into 3D and into machine learning, depth synthesis, GANs, and nerves. That was a very early example of something I've done in Midjourney, and also in my workshops, I also teach sometimes. I managed to create a workflow where we can use photogrammetry first. So that was the first stage, using photogrammetry to create a specific sculptural art piece into 3D form. And also the image to the right is an image created using Midjourney. And the process and the images to the left is in a specific program that I was able to recreate these 3D meshes. This is another example. So the image to the left is also using Midjourney with the depth map, and using the same process, I was able to replicate the 3D organic fluid space inside the Unreal Engine design. And these are some examples of how we use these 3D meshes and explorations inside another tool, which can create some immersive spaces. So we're taking it further down, not just stopping at the 2D barrier. So these are some examples of similar simulations, but based on the same concept, same mesh. And now we're moving into GANs, which what Neil was mentioning before. So the image to the left is a series of a training set, the data set that you input into the program, into the platform. And then to the right is a series of fakes. So this is just one of the rounds. I like it because it can, you can see the contrast of the two images. Just one of them is still in the process. Basically, this is how GANs work, by generator and by discriminator. And then you have an outcome. And this is another sample. So this is a star GAN to the right. It's a bit on speed star GAN. It's quite interesting as well, because that was one of the earlier explorations I was doing using the fluidity concept and these immersive spaces and how I can translate these into a 3D form. And that was one of the processes that I was doing, and I was able to get that into further down the line into something a bit more as a wireframe mesh. Furthermore to that. And then this is just a short clip just to show the potential of getting an immersive space out of these simulations. And now moving on from GANs, now we have another type of neural networks called NERFs, which is neural radiance fields. It's also an exciting tool or development that I was experimenting with after Midjourney. Like, this is one of the processes. So the way it works is similar to photogrammetry, but in this case, different to photogrammetry, you can actually fill the gaps with this neural network, because there are some certain limitations with photogrammetry specifically. But this one, for example, the way it works is that you have an image or you have a video and you can generate different camera angles. And from that point, you can create a 3D scene, which is also a 3D mesh scene, which is an OBJ, which is something you can take out from different situations. But what I liked about this is that it has this also immersive vibe into it. So most of my work has been into Unreal after the 3D process. So there's a lot of immersive notion connected to my work. And so the image, the video to the right is using NERFs. It's a real footage from the train station in New York. And I just wanted to include it because I find it quite exciting and immersive at the same time. It's from the real world. And going from the real world to the interiors and the abstract motion. So the image to the left is a 2D render of the simulation that I've done, experimenting with fluid design and the organic shapes. And from that specific image, I was able to replicate the 2D scene using AI. And from that scene, I was also able to replicate a 3D scene from that specific one. And that one was using neural radiance field with Luma AI specifically. Moving on from that, so the same process, these are some examples of my students' work in the workshops, so different simulations inside the Unreal Engine, quite immersive worlds. They're quite artistic and basically, yeah, quite immersive in a sense, because that was one of the main concepts of creating these worlds inside Unreal Engine. There's a very strong notion between creating these worlds and like the AI and in the Journey or any other platforms. There is a strong connection between the process from that point into getting into a 3D space. And some other potential experiments we can create also in Unreal Engine. Quite cool. So we're getting into an immersive space. I think AI is becoming quite evolved. It's technologies that we need to work with and experiment with and try to get the best out of it, but at the same time, keep in mind the negative side of things, because I think I'm a bit more on the optimistic side at this stage with AI. And I think we need to keep that notion until AI becomes sentient and we go to the matrix. So my question to you is, which pill would you take? Would you take the blue pill and stay in your comfort zone and not embrace this technology, or would you take the red pill and jump the rabbit hole like Neil did? Thank you.
Do you have a All right. Good afternoon. It's great to be here in Venice. Thank you very much for the introduction and the invitation. I'm going to talk about the work of my design research laboratory at RMIT. It's the RMIT Architecture Tectonic Formation Lab. I also run an architecture practice, Snooks Harper. But I won't be showing that work today. But what I want to really do is I want to frame the work that I'm doing in terms of two diametrically opposed ways of understanding the world. And one of those ways is to understand the models from which phenomena arise. Another way of understanding the world is the artifacts or the surface effects of those models. And when we think about this in terms of design, or particularly computational design, we can understand this as generative models where you write the underlying rules for something to come into being. We've talked about this as being generative design for many, many years. And another way of thinking about something is to be able to explain the surface effects. And this is what happens typically in generative AI. When we write a prompt, what we're doing is we're explaining what it is that we want to create at the level of the surface effects, at the level of the artifact. We're not talking about the underlying model. But I think design intention needs to operate through both these modes. We need to understand the world for its models as well as its artifacts. And what I'm attempting to do is to create a design process that deals with both of those. More than 20 years ago, I started working on a type of algorithm known as a multi-agent system. This is a process that I describe as behavioral formation. It's an approach which draws on these algorithms and the logic of swarm intelligence. And it's a process in which you write the underlying rules for a set of autonomous agents. The interaction of those agents then leads to a type of self-organization of design intention and the generation of proto-architectural forms, structures, orders, etc. So in doing this, you're writing the underlying rules for something. You're not describing what it's going to create, and in fact, that's the whole notion of emergence. That you can't control what it is that it will make. That is what emerges from the process. You're not describing that. The types of geometries that we would create from this are highly intricate and detailed geometries that have these emergent qualities to them. Reifying those in built form is hugely problematic. So at a small scale, it's easy. This is a direct 3D print there's a series of these in aluminium and in titanium. And I guess what these prints are doing is they're a direct reification, a direct construction of this highly emergent geometry. But more recently, we've tried to scale this up to try and work out, can we go from the sort of micro scale into something that has more serious architectural applications? And in doing so, design intention has to happen at all these different levels. You can write the underlying model for something that leads to its generation, but you also have to deal with a whole series of other criteria that have got to do with how it's fabricated, structural integrity, there's a whole lot of things to do with building codes, etc. And so increasingly what we're realizing is that we need to be operating at both these levels, level of surface effect and underlying model. And this is where AI can be very useful in what we do. And this is work coming out of the lab where we're using reinforcement learning, which is a type of machine learning, which what we're trying to do here is we're trying to basically train the agents to make better decisions. And we're trying to train them with top-level surface effects criteria, which then gets fed back into the underlying generative processes. So this is something we're working on with one of our researchers in the lab, Da-Song Wang. And so I guess what the lab is trying to do is look at this relationship between generative algorithms and robotic fabrication. And what we do is we build a series of demonstrators in the lab. And these demonstrators try to bring together a series of different research and to test that through design. So we're also looking at this type of work in terms of robotics and the way we can write the underlying rules or train robots rather than using more traditional inverse kinematics to then try and build, sort of test how this works at a larger scale. So this is, I'm going to very quickly cycle through a series of projects done over the last 4 or 5 years, which are looking at large scale additive manufacturing and the way that's been used to generate, in this case, a installation at the National Gallery of Victoria. A lot of these are looking at the relationship between structure and skin. And so this is the start of a series of projects we've been doing with Boeing, in which we're trying to embed carbon fiber in 3D printing. So we're looking at the relationship between structure and skin, where a skeleton gets embedded within a skin, and we overcome some of the problems or limitations of 3D printed plastics, which has got to do with directionality of layers and the inherent weakness of the material that we're printing in. This was the first of that series. This was exhibited in 2019 at the Shenzhen Architecture Biennale. A more recent version of that was acquired by the National Gallery of Victoria. was really an attempt to try and rework a lot of those systems and involve things like redesigning new extruders, try and improve the print quality that we're working on, and then to reimagine the whole system of jointing. So we're no longer thinking about mechanical joints, but also shift into a system of chemical joints. In the last 4 or 5 years, we've done a lot of work with large-scale metal printing. This enables us to print very fine, intricate metal sections that allows us to scale up into these sort of larger elements. This is a process that's known as WAM, or wire arc additive manufacturing. It's effectively just a MIG weld on the end of a robot that's laying down 1,000-degree steel in this case. I think I have a video of that process. And this is an example where we can start to make structure and skin become the one from the one process. And we've now got a way of printing things which are structurally stable as opposed to reinforcing them as we were with the plastic printing. So over the last few years, we've been working on writing software to try and develop the fidelity of this. And one of the things we realized is this is not something that can simply be calibrated from bottom-up process. It needs to actually have top-down vision systems and feedback, and AI is an essential element of that work. The last of these projects I want to show is work we've been doing. This is a collaboration with Maple Glass Printing. We're starting to print in glass rather than plastics. And so initially, this is only happening at a very small scale. But what we've been doing in the last, well, what we're currently doing, in fact, yesterday we made the first viable print of this, is we're making an extruder that goes on the end of a robot, and we're now starting to print glass at a large scale. So a lot of the work we've been doing in plastic, we now want to try and develop into at a larger scale in glass. So this is what you're seeing here is printing on a very small glass printer in a build chamber that runs at about 700 degrees. We're now doing our first tests at printing in ambient room temperature. This is one of our first tests where we're looking at the relationship between WAM printed frames and glass printed glazing. Now, the last thing I want to, I'm not very short on time, so the last thing I want to talk about is work we've been doing with our students, which is using AI in different ways. So it's not about training the generative models we've had previously to become more sophisticated, but instead it's about using them to, I guess, mine the possibilities of developing a language or a formal logic. This is work we were doing sort of 5 or 6 years ago with the students. We'd asked them to make all of these objects as an interaction between generative bottom-up algorithms and painterly operations, gesture operations that make these sort of proto-architectural chunks of form. In the last year or 18 months, we've then been asking them to do something similar, but by using generative AI. So they're trying to create, instead of trying to create, this is what we don't let them do. So what we don't let them do is create things that look like architecture. Instead, what we force them to do is we ask them to make an architectural language, which is about the tectonic, it's about texture, it's about form, it's about these things which are not directly a piece of architecture. And then we wanted them to try and make it into architecture through a much more deliberately convoluted process. And so they produce these types of images. We think of these as sort of chunks of architectural tectonic, which have various different qualities. And then they go through processes of going back and forth between this type of image, which are just image generators through diffusion models. Then they go back and forth with generative bottom-up algorithms, as well as direct modeling. And we make this back and forth process until we can create something which doesn't index its process of formation. It's neither something that's come from a GAN, a diffusion model, nor is it something that's come from a bottom-up algorithmic system, nor is it something that's directly modeled, but it has certain qualities and characteristics which come from all of these things. And what we're trying to do is we're trying to get away from the problem of diffusion models, which are trained on massive data sets of existing images. Therefore, it's only ever going to replicate things that already exist. We're trying to create something where we can actually make an architecture which has an original set of characteristics and qualities. And so we go through these different processes of thinking about articulation and form and modeling and going back and forth to create this type of work. So just to conclude, I guess what I'm trying to say in this work is that I don't see I'm not sure I agree with the title of AI revolution. I think it's much more of an evolution. I think there's a possibility of embedding AI and these processes into the ways we already work, as well as finding what are the opportunities of these to try and create something which I guess, draws on the most interesting qualities of these different processes and doesn't limit us just to thinking about what are the surface descriptions of things we want to make, but actually trying to understand what is this relationship between models and surface descriptions. Thanks.
I should be ready to go in a second. Right. So thanks everyone. Thanks for having me today. It's great to be able to have this conversation with you all in this amazing venue. As you mentioned before, my name is Sara Codarin, graduated from the University of Ferrara. Now I'm an assistant professor of architecture at Lawrence Tech in Detroit. And I want to use this brief presentation as an opportunity to introduce to you three projects I'm working on as some research, but also as some outcomes of the classes that I'm teaching at different levels at Lawrence Tech. And so I will frame like the technological environment that we're talking about specifically in terms of text to image generation, right? So like trying to understand what the possibilities of AI are and how to frame them in higher education, like how to convey a methodology to students so that they have the tools and the skill set to really address in a culturally based way these kind of opportunities and design thinking opportunities. So just to start, I want to frame a little bit of my interests. I do have a background in architectural restoration using robots, so very much theory oriented, thinking about like the possibility of adding layers of technology when it comes to architectural conservation, when it comes to interacting with buildings with artifacts that have high collective value. And I like to think as this kind of investigation as an opportunity to look at collaborative use of workspaces in this kind of sites that can be actuated by humans, by machines, and in the framework of architecture restoration. And I'm interested in this kind of setting because of the geometry, because of the complexities that are related to that, you know, and because of like kind of the need of like responding to data collection and fabrication in a sort of like high profile way. And so to me, like using AI, since you know we've been talking about like the tools like DALL-E and Midjourney when they became available to a wide audience last year in the summer. And so that was a starting point for me really to start building a visual palimpsest of like novel space occupancies and novel layouts in which we can imagine this kind of interaction happening. And I'm using robots to create this contrast in this kind of visuals as possible applications, as possible tools that we can observe in this kind of processes, and also as a way to highlight a foreseeable shifting culture of automation in service of craft, in service of customization and high-profile conservation projects. In these examples, most of my references come from the Roman culture, has a very extensive amount of potential test cases. And to me, like AI image generation also is a way, and that's something that I try to convey to the students, right? Is a way to build a literacy of places, of architectures, of forms, of languages. We've been talking about that a little bit, and semantic elements that are really crucial element when it comes to text to image generation, because we are using the prompts, we're using inputs that come from the natural language to obtain this kind of outcomes, this kind of images. And to me, the hybrid realities that can be crafted using AI are also a way to add a layer of interpretation in our collective history, in the objects that we interact with. And kind of like this kind of imagery also can be seen, for instance, with like very specific application cases, like the use of color in Bernini's Baroque sculptures as a way to kind of like merge the cultural heritage and like in a sort of like two-dimensional way conceptually. Then to build on some of these examples, get into the teaching part. This past spring break at Lawrence Tech, together with Carl Dahlman, the dean of the college, we took a group of students to Rome, 25 students, as an elective class. So for us, really, is a way. I'm already on my second or third class that I'm teaching related to these things, the LQ. Because again, we want to build a cultural framework to have like technology-informed conversations with students. And in previous versions of this course, when we went to Rome last year as well, we required the sketchbook, right? That's what you do when you travel with students. You want them to make observations, to take notes, to observe the things we're seeing in the different sites. And we consider that a learning device. But like, of course, we were curious about the recent developments with AI and image generation. And so basically the course shifted from analog sketching to the creation and design fiction per book using AI. And maybe some of you know this reference, but we were inspired by the project Roma Interrotta that was developed in 1978 and interrupted Rome. And that focused on reimagining Rome. And I really love the fact that we are using the same terminology when it comes to that culture of design and when it comes to AI, because we use it, imagine as a way to prompt things. And at the time with the Roma Interrotta project, basically a group of designers focused on parts of the city that were unplanned at the time. And so, like with all of this, like we framed the topic, the location, the experience, and we asked students to create a disciplinary third book. And so they started to reinterpret the past, the present, and the future of Rome. And we can see some examples, imagining the she-wolf designed by Bernini, because the rationale of the student was that the she-wolf is a static object, is a static statue that kind of doesn't give justice to the tumultuous history of Rome. And so thinking about that through the lens of Baroque, what happens, and can we have a conversation about that? Another students imagined a future in which some scientific revolutions happened and occurred, and then imagining St. Peter's and the Vatican as the sort of headquarters of a scientific institution, and imagining Galileo Galilei's statue as a way to celebrate that and to bring kind of like a novel symbol into the city, adding like on top of the other layers of the history of Rome. Piazza Navona Film Festival, all these are student work, the outcomes from the spring course, and this in particular, like again, as a way to use AI to sort of like develop creativity, to learn how to be creative, to have a culture that will teach you how to be creative. It was interesting how this is a reference to Christian Robert Scholl's idea that Rome is a sequence of urban interiors, and that is sort of like creating an interior using one of Rome's piazzas. And then also locating monuments in altered urban scenarios. Again, another reference to the Roma Interrotta project. Venturi did a collage that was very provocative, and that was an important reference to start developing this kind of narratives. And because of the interest in technology, us developing this in Detroit, and also talking about Italy, there's like, I have an extensive amount of images, of course. I'm showing just a few, but some of them will be selected for an exhibition at the Italian consulate in Detroit. So I'm bringing the culture there, and we can have this kind of conversations at some point in September. And just finally, real quick, also I want to tribute the geography of my workspace, where I'm located in Detroit, sort of the core of the automotive industry, and to talk about this idea of thinking about Mobile Detroit 2050, the title of the project. It's an exhibition, the proposal that has been selected for the Detroit Multi Design. And that will come also with an international call for images. So you all will hear from me soon. Because for that event, we really want to think about, again, like situating a project, understanding the perimeter and understanding how to craft that and work within that system. And really like having in mind the idea of thinking about the future of mobility in Metro Detroit as a technologically advanced location. And again, using, this kind of semantic area, reimagining Detroit, which is the core of the automotive industry, how can we filter through the lens of AI, think about an innovative and sustainable way to think about transportation, to think about sustainable mobility, and to think about the ways really to create a storytelling, to talk about transportation infrastructure, and then back to the history of the place and back to the history of the sort of like the manufacturing, the production, and the automotive industry heritage that is present in that location. And with that, I'll thank you a lot. And next. Yeah. I think it's here. Oh, we got it. What?
Sorry. Little bit of help on this. Okay. Yeah. Did it work? Perfect. Okay. Okay. Thank you. I ignored it.
Okay. 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 I think we should. Yeah.
So I don't know how to go to next.
I think we can just. This. Oh, interesting. Oh, that's good. Is that the different one?
No.
Probably is. We do this. So we also.
No. No. Maybe it's too many slides.
No, I don't think we can see. Do you have also a PDF of that?
No. Maybe it's too much. I just read only.
Oh, okay. Oh, the PDF problem.
No, no.
No.
What is this? It works.
Oh, okay.
Sure. Yeah. It's on the page. Okay, thank you. And it's my honor to be here. As you can see at my face, I'm from East. So it's very difficult to get here today, but anyhow, it's my honor to be here. I usually talk online, and like some people may know that we are doing artificial intelligence since 2016. So my team and us created this company called Xcool. Leo also expand. And what we're doing is basically using AI to change the architectural design, not just in the sense of the design itself, but also the tools we're using. So we look into the workflow of the design procedures. As we all know that it comes from the requirements from the client and also the condition on the site and the regulations, and that is the inputs. And later on, we need to do several procedures, like we need to find the possibilities to do the concept, and we do the like detailing, and then we do the budgeting, and finally we get the decisions. And today I would like to introduce the things we are more working on, the possibility searching, which starts from like 2017 on. And you can see on the left side is the data we are extracting from the maps to understand the plot relationship with the buildings. The red are the buildings, the blue is the plots. And the right side is the tool we generate based on the cloud with those algorithms trained with this pre-trained with this data. So it can automatically generate the results out from the inputs of the plot. And this is something we have it like, already 6 years ago. And later on, we also focus like on the GANs. The previous one is more like a CNN, convolutional neural networks. But here it's like we are generating images, but not just images, but on the right side, you can see it's the relationship between the rooms in flats. So at that moment, we are thinking, can this generation is not just using in images, but the GAN models can also use for graphics and vectors. This is the starting point. We are kind of linking this graphic with the images, so people can, or the students can just do very like a sketchy stuff on the side and left side and the right side image were generated. That is the Shenzhen Biennale, and the right and the upper left one. Upper right one, sorry, it's the Venice Biennale. Actually, last time we were there, but not really there. We cannot count here, but it's in the Chinese pavilion. We're trying to connect the different styles with this architecture office called Open. Lee is the kind of founder of it, and he was working in Stephen Hall, and we're combining his style with the Chinese courtyards. And this here, we also start the moment with the graphic image and the models. On the right side, you can see it's the 3D model generated out from these bubble sketches from the user architects. And all those design elements within this, like here, like the floor plates or the layouts are generated by the machine. And you can adjust it simultaneously with the machine, and eventually can get you what you want out from those relationships. And that is the 2020 to 21. And last year, we also did this diffusion model, but more in thematic with the Chinese culture and the more like architects vocabularies, let's say. Because, for instance, majority cannot really understand who is Zaha Hadid. It might come with something else. And what is the window means? Yeah, window maybe you understand, but what is the elevator shaft, for instance? It's not something the machine as the standard algorithm can understand. So this year we also launched this plugins, which is you can use for Rhino or for this SketchUp. It's an online platform, but you can plug in with your software. So just do any sketches you want with the massing models or detail models. Then the machine can generate you with those beautiful images. But we are not really satisfied with it because all the things about AI and with design is like controlling. So we kind of launched our new platform. Neil also mentioned it like the beginning of this month or 1 or 2 weeks ago, which is containing 3 major parts. First is the intention generating, and second is the fine-tuning training, and finally is the co-sharing. What is this? That I will explain quickly. First of all, we kind of based on our archive, we call it ArchiNet. It's some kind of database we collected for past 7 years, like tons of millions of the architecture data, which includes like different scenarios of architectural field, like architectural, also interior, landscape, master planning, urban planning, etc. And we pre-trained this model with the diffusion model algorithm, and we got this 3. We call it the large model of ourselves. Not just with the model itself, but with a really, you can see there is a really high demands of the calculational power, as well as we improved the algorithms in the really fundamental layers. And here are the difference. If we just use like an overfitting model on the bottom side, when you key in some prompts, it will always be the same, which means when you say like the top is the prompt, when you do a residential building, high-rise evolution modernism, yeah, like our model and this overfitting model is more or less the same. This overfitting model is a kind of our failures in between. And secondly, when you put in something else, like you want a street view and with Chinese style, or you want this futurism style, or this afternoon sunset, the lower part has no response to it because it's just a general model. It don't really understand what you need in terms of architect's demands. And this is the way we improve it with these large models by ourselves. And based on it, we have this intention generating or inspiration generating in 2 ways. One way is, as everyone already tried, this text to image. So you input prompts and then give you images. But those images are, to be honest, too random. It's like something you just pick up from, I don't know, a lot of goods. But the image to image is something you can really control it. I will explain that later with the video. And also, we provide our users to really train their own models. This is very important because nowadays you can only use the application layer of, for instance, Midjourney is a kind of a closed society. It trains its own model. It's not for everyone. So there's a lot of people starting to use stable diffusion, which means they can to do their own models. But stable diffusion has some like a difficulty that you need to set up your own environment and you need to have your own data set. And it is a large computational powers to get your model can be trained. And this middle layer of this model training is something we think our users, architects and designers is needed. So we provide this function on our cloud platform as well. And finally, with the image generation, or those intention generation, and these models already be trained, we have this so-called a kind of a co-sharing community. So all the images generated, you can just share to others. And also the models you trained with your own data or your own preference of the data sets, you can also share. This is how it looks on our platform, which has already been used for like 2 weeks in China. And we are open to the world in end of the month or beginning of next month. And you can see on the left side, this is all images that users are generated like, from everywhere. And the right side are the models they trained. It's like a LoRa models, low resolution stuff. So there's a low ranking adoption models. And here is a video about it. Maybe it's easier to just play it. Sorry, if it's working, yeah, with the sound. So all the images here you see is to be generated by our platform. It's so precise, and especially the line are very straight. This is very important, right? Because a lot of times when we generate with the models, the lines will always be weird. But here we can do those prompts as usual. This is a text to image. Just select the LoRa models or our base models there, and you can get different outcomes. And the important thing here is very fast. 10 seconds, you can get the 4 images out from it. And it's very precise. Of course, there's some more things about this text. Is you change the interior, exterior, it's all fine. And you can add your LoRa models. This LoRa model is being trained maybe by someone else. And you can use it because it's a share in this model algorithm, or it's called a model markets. And you can just use theirs and set the percentage, how much you want to use it. And you get a lot of different results based on other people's this LoRa models. And those are the text to image. You can get this reference image, that's a image to image. You want this one as the base image, and then you just input what you want as the prompt and control it. Just upload. For instance, here is a random interior, and input this image with your prompts. The image will generate you the results immediately. And we have this render mode, which means you can directly render it out with your model or sketches, like hand sketches, very precisely. So this is the result out from this hand sketch. And as I said, the most important thing is that we can create tools by ourselves with those models. Here is we can control it, like editing it. We just scratch on those parts we don't want and ask the machine to regenerate that part only. So you will see it's immediately change the existence of the entrance only. And also you can do this entrance again, maybe with wood, whatever material or intention you want. And it can be regenerated. A few seconds, it can get a new one. That's it. Of course, if you don't like this building at all, but you like the environment, you can change this building only and ask the machine to do their thing for this building only, and regenerate it. That's it. So it's something I call controllable. And this model, we can do fine tuning. Just grab the pictures you want from your own shoot and upload to our platform. Maybe you need 10 minutes to search for those images, but 1 minute to set it, 10 minutes to train it. Then you got your own LoRa model. For instance, here I got mine, then I can use for any further generation I want. And finally, those things can be shared. For instance, this model, if someone using your model, you can also charge them for 1 coin or so, or they can also share it with others. And also here, we have this kind of sociality, so people can like your photos and or share it with others. Oh, sorry, there's a few more things. If you find something in this image plaza or inspiration plaza, you can just copy what is the prompt of others. So you can just do this iteration based on the other's work and to find your own style out from all those testings. Here you can just choose others, and all those coins goes to the creator of this model. It's pretty fun, isn't it? We compared our model with the major players like the Midjourney. You can see here the Midjourney has a very limited response to what we want to describe. Here is the same prompt we put in, and the lower part has this little bit greenish stuff, but maybe not the style of architects. And we also tested some other prompts with Midjourney. Like this one even worse. It's not just not the thing we want, but the upper part we trained with own data and we fine-tuned it. It's so, I mean, architectural. And also we tried with stable diffusion, because stable diffusion, especially for the 1.5 version, is something very generic and it cannot really be used for architectural design or intention generation. But here we trained with our own data sets. You can see those results are really precise, and this is something we really want. But the lower parts are, the quality is not good at all. You can see the image is really blur. It's not something architects can accept. But yeah, we trained with carefully with all the details. And this is something we conclude our new platform is really like avoiding the disadvantages of the stable diffusion and Midjourney. As I said, Midjourney is a closed source. It can train its own model, but here we are really open the source for everyone. Everyone can train their own models and use it. And you don't have to set up all those environments by yourself, but all those LoRa's, you can just train it in 10 minutes. So very, yeah, convenient and very hands-on, handy. And that's as a conclusion, I wanted to share our future version or future vision. It's not just with generate images. As you also saw our history, we got a lot of the different tools already be developed, and which we will all include into this AI kits. What this AI kits can do is combining with the so-called Chat GPT or Chat GPT 3.5 below. There's open sources. We can train for the architectural usage. For instance, here, if you want to do some kind of real estate development, you can ask this chatbot for resources of, like in Guangzhou, what kind of flat is popular. And then using our tools and apps, these chatbots can directly apply onto it. Like here is the previous you saw that can generate plans out from this, we call it this building creator. And also in our master planner with this 3D, you can get this very rough, mapping and ask the machine to generate images out from this. But it's a very precise with the inside is all those layouts are there. And it's just like the chatbot is linking all the tools. And then we can generate CAD elevation out from this. So on the right side is generating the CAD file out from this. And you can just editing further on top of it, as well as this thing can also be generated as a 3D models. So if you request for 3D models, it will be based on the previous plans and this elevation to get what is your want for this model. So it's basically the future way of the workflow. This is just one example of it. We work with the tablets, and there's a different apps like behind it, and we can combine those apps and really to mix up with a lot of different things. This is something we think that is the future, not just Xcool apps, of course, not just the Look X tools, but can be anything. And the machine will guide you to a really efficient way of working. And in the end, we are not building this like only by ourselves. We are really want to build this with every architect. If you want to do something, we can do it together. Because today, with the help of AI, we can generate our own tools, not just by training, but also like coding, etc. So that's it for my today. If yeah, we can different. Thank you.
Okay, that was really brilliant. And what to say? I mean, I think that we are all here, guys, because of one main thing. We are living a kind of plot twist, you know? I mean, we were all expecting a great infusion of AI, I like to say, on the left side of our brain, but actually is fueling our right side, you know? Imagination, you know, something that always has drive human beings is like powered by the AI. And you know, my name is Arturo Tedeschi. I'm an architect. I'm a computational designer. I like to say that I'm a computational designer. You know, it's a kind of common definition, even if it's not a real, you know, profession somehow. And you can see in my work, I always like to say a kind of technology wanderlust. I started from scratch. I studied years ago, started by, you know, using pencil, papers. And then my travel, this wanderlust, brought me to, you know, exploring so many different things. So you cannot recognize a particular style or the adherence to a particular manifesto. I really like to explore manufacturing technologies, different techniques. And I also came up by like writing some book, Architettura Parametrica, Parametric Architecture with Grasshopper. Grasshopper is like, I like to say, the extension of my hands somehow. And I deeply believe in this sentence by Marshall McLuhan. First, we shape our tools, and thereafter they shape us. I mean, if I had the opportunity to explore, again, different projects for so many industries and different typologies, it was mainly because I got some tool that augmented my capabilities, you know, otherwise it was not possible to do it. And this is a dialogue that I want to do. You know, I taught here in this place. So this is a kind of dialogue with students, with people that maybe for the first time, they are, you know, astonished by all the power and the incredible outputs that we can get using, you know, this kind of self-learning tools like AI, diffusion models, you know, so many different words and definitions that maybe probably they are overlapping in your mind. But let's say that for sure, the last 30 years, they were dominated by the so-called free-for design and architecture. And that was possible, you know, thanks to different methodologies that we used and developed. But if you analyze everything, I mean, everything is based on a single mathematical formulation, which is called, you know, Bezier curves. Then they were then developed into NURBS, and then we have meshes and sub-D, and then algorithmic modeling with visual scripting, Grasshopper stuff, Python, C#. But everything is based on points and curves. It was based on points and curves. Some of projects I worked on, this is called Sistema Fessura, is a wall system that was created and manufactured using LG HiMax, and we work with thermoforming procedures and, you know, curves. This is a collaboration with my mentor and great friend, Ross Lovegrove. This is a project that Ross developed for United Nude. It was, and this is still the most complex project I worked on in my life, and I work in, you know, automotive, skyscrapers, everything. But that was the most complex thing to work. And, you know, we work with super complex lattices, gravitational forces, particles, springs, you know. So again, points and curves. You can see the algorithmic definition we used for that. And then also when you go and we used different technologies, for example, this is a chair, but that was just the opportunity to use different techniques. For example, this is a real thing. We created all this thing using virtual reality. Years ago, before, you know, the Gravity Sketch easy tool, that was a platform called MindDesk. And the idea was to create everything in the metaverse before it was called the metaverse, because we are talking about 2018, more or less. with this idea of no blueprints, from a digital world to the digital manufacturing with a seamless technology, and everything was created with a robotic arm. Now, we were expecting machine learning and AI in the left side of our brain, where they intersected for the first time. More or less in 2015, when we started using, machine learning algorithms within 3D modeling software. This is the Finch 3D tool. It's a very famous one. Or, this is Grasshopper that brought some, thanks to Lunchbox, with the Grasshopper plugins, we had the chance, the opportunity to use, for example, the k-means clustering, meaning that you have the possibility to clusterize and think according to similarity. And that was game changing. With that, within Grasshopper, within a left brain side of things again, something that I like to call also analytical thinking. This is a project that I developed with another friend, Giuseppe Leda. And here it is a wall system where you can see different apertures there, and they were selected using a machine learning tool according to similarities. And again, we were integrating somehow machine learning with 3D modeling tools. Now, what's the minus from my perspective, from a standpoint of a guy that grew up in Italy? So where the category that we call beauty is essential. Algorithmic thinking and analytical thinking somehow bring this problem to me. The design process is overlapped with ideation. This is a project I worked on, where in order to get that kind of model, I had to use a topology optimization tool. So the ideation and the process, they were overlapped. They were not two distinct moments. And so where the block is, somehow, style gun was invented. Neil described perfectly the thing. But architects and designers, they were not interested in that, But we have these amazing gaps, through age. This is myself in a few years, probably in a few months if I don't sleep that much. And the first time I used style GAN was for a Christmas doodle that I did on my Instagram 4 years ago. No one understood it. They were saying, "Oh, Arturo, nice merging between images." I mean, it's not a merge. It's not a morphing. It's something more complex. Oh yeah, cool Christmas tree. And then I started, like everyone, playing with brutalist architecture. I tried to combine it with Grasshopper and so on. And I mean, shoes, portraits, Renaissance portrait combined with Grasshopper geometries, and etc. But meanwhile, we were trying to prove to the computer that we were not robots. And so we were, selecting traffic lights, fire hydrant, bus, and etc. We were feeding the machine. We were feeding the monster. And as Neil said, that was the beginning of the image labeling. And so this process was flipped at a certain point. So you start with language and you came up with images, And so why architects and designers suddenly 1 year ago, more or less, they got all this interest? Because, these kind of tools, platforms, diffusion models, they register the latent relationship between the complex data. This is what we do every day when we imagine new things. When architects, they start imagining something, they connect dots in a kind of latent way, in a latent space. It's not always a bottom-up logic. It's not always connecting the dot A, B, C, D. There is something more mysterious. Let me use this word. And then we were expecting again AI influencing the rational part. But actually, in 1 year, from March 2022, when Midjourney was out till now, we are actually fueling that part, imagination. Something that we realized is that human beings they discover this kind of energy, you know. If we go online, you can see millions. We can see the photo with the white Montclair, you know, what's that? And where there is the main revolution is that we are separating somehow the moment of ideation with the design process and then manufacturing. So somehow we are getting back to this idea where ideation is something that which is disconnected from the mechanism, the mechanical part, the design process, because we are human. Sorry, I'm Italian, so for me this is very important. But we are still human, so we need to infuse something which is more than just technique, because otherwise our profession will become completely replaceable by a machine. You know, there is something that we have to keep in our design. And another silent revolution that happened is that for the first time, and I'm talking about Midjourney or DALL-E, there are tools that work inside as a kind of social network. You know, we are not using anymore a software to be installed on the computer. It's a messaging app, and this is revolutionary. You know why? Because it accelerates the learning process. We are working and chatting with other people because this is a social posture. We are all living with phones and smartphones, and you know, everything, it's in the same place. And it is this is a revolution also in terms of learning, you know. And just in conclusion, because we don't have so much time and I don't want to impress you with amazing images, is that the second revolution, which is deeply connected with self-learning mechanism, is that I guess we are slowly moving from the analytical process we were talking about. I mean, this is a metaphor, of course. Imagine a keyhole. Until now, we developed keys in a kind of analytical way. You know, we disassembled the problem into simple pieces and then we connect the dots again. AI is giving us this new paradigm. I mean, we don't need to design the perfect keys because the machine will develop billions of keys. And just one will be the right one, but in a kind of synthetic way. So it is a new approach. And so the future of our profession will be about being, to say, AI, all these kind of tools will be like co-partner of our work. We will be the one that pick up probably the right key to open the door. Thank you so much.
I thought of it. Okay. We got to take those down. Yeah. It's going to be. Go ahead. We've got to go reconfigure for. You go ahead.
I think you sent it, right? Is it?
Yeah, that's it. So I just pressed the mouse.
Yeah, but
Screen.
Right? And then your screen feels and then either is good.
Okay, thank you. All right. So my name is Tim Fu. I work as a data architects, and maybe just a little bit of introduction since I'm with such an esteemed panel group. So I work as Zaha Deep Code. We're a computational research group where we specialize in advanced parametric computation and algorithmic design. So within that paradigm, we do a lot of things related with design and technology in the broadest sense. And ever since I've also gotten into AI research, I've been doing a lot of teaching on the side as well. So how did I really start with AI? On a fateful evening of end of July of last year, which is not even a year, I started seeing a lot of images being shared in social media. So things were tagged with designed by Zaha Hadid. While they were very interesting, I was very interested in it. I started to analyze it, and I think that there's a lot of things that are also very unlike Zaha Hadid, as I would say, and I think some of us here would agree. It's a bit more chaotic, less refined in that sense. So I was more so inspired to also give it a try myself. So with this one here at the beginning, I started to just explore in the depth of it, just through the chaos and see what I can do. And this was a rather free form artistic expression for me, where I just think, you know, let's do whatever I think is the most interesting visually. But then after a certain point, I practiced architecture, right? So I wanted to see what it actually can do for us in the broader spectrum of this industry. So I started to tone down the design. So that's basically at a point where I started to realize there are certain rules and patterns and ways of prompting that can get you to get what you want. And a lot of the times you start with a lot of chaos. So you have to work against it. And when I started sharing my stuff on social media, which gained traction, it was through the goal to try to actually tone things down and think about feasibility and construction, so that we can actually consider this technology as a viable solution to architectural design. And with that, I was progressing my techniques while the technology was progressing alongside. At the beginning, you know, we had Midjourney version 3 was when I started. Very short time since then, we had Midjourney Test P started introducing a bit more photorealism. And then just shortly around the same time, I got my DALL-E 2 as well. I was one of the later ones to get it. But at that point, I did some experiments. It was interesting. But I think comparatively, at some point, I think it's Midjourney all the way. And I think every panelist here probably agrees with me. Some of you, maybe. But it's good because it has that sense of aesthetics that we really try to seek, both as architect and as artists, if you will. And so I try to really explore it by trying to introduce new design, as well as trying to curate aesthetic qualities of it. So that's how I've been trying to share my work on social media. And from there, you know, I got in contact with Parametric Architecture, which is a platform that teaches usually computational skill sets related to architecture. And so I started to really systematically codify my observation through my research. And with that, I started to teach both Midjourney architecture and Midjourney design in a way that is more kind of laid out for people to actually trying to understand the technology, try to see it as tools that can be controlled, can also be driven towards what you're trying to achieve. So less chaos and more control and human intention. And in order to continue progressing that narrative, I also try to see how much other ways I can incorporate our human artistry as a collective, human artistry to AI. So at some point, I really got into sketch to render as well. This is where you really, you know, take a pencil and a paper and then just start doing what we call multimodal input. Really, it's just images and text. So with a combination of the two, by incorporating my images through Midjourney, as well as sometimes I use ink sketching, I was really able to start to produce things that are well within my control. So I, you know, carry with me the education that I have through AA, as well as the design ethos has been instilled with me through working as Zaha Hadid architects. So I think a lot of this stuff is slowly able to become more so incorporated within Midjourney architecture. And so if we zoom out a bit on a broader spectrum, I really like traditional architecture. I really like, you know, beautiful Venice and stuccos and just beautiful classical architecture. And sometimes I explore that through a new lens. So always got the Zaha Hadid thing going on, but there is such a new way of introducing things together now with AI that we can just seamlessly sort of merge design languages. So kind of language can now travel through time, and something like Gothic architecture can now be sort of always reimagined with a sense of futurism and contemporary nature. And again, I did the same to experiment with designing Renaissance interiors and seeing how to bring that to a new light. And so how do we really go from just pictures to reality? This is where I started working on trying to formulate plans, early plans, to get AI to become materialized in the real world. I started with, the Renaissance interiors. I started breaking it down to elements. So we have at the beginning, columns and capital and beams and etc. And initially, so I just took one little element, such as the column capital, and try to imagine what it can be designed with AI and how I can bring a bit of futurism to it and perhaps also fluidity. And so I started working with a stonemason in Germany, Till Affel, to start to materialize this process. The AI image, I've interpreted the idea of the AI image and rationalized it on my end, how to represent it in 3D. So that's through just our typical 3D softwares. And once I made the final copy, I provided the drawings to the stonemason. And then that's where it gets interesting, because he's now carving it with his hand. So I think if we zoom out, it's interesting because there's a bit of that revolution, as Arturo has just said. It's like we are coming to a point where things are fundamentally shifting in our industry, potentially. Traditionally, we have human ideation followed by machine fabrication. That was the predominant narrative of the Industrial Revolution. And so things were prefabricated very modularly for high efficiency and mass production. And so now, if we are able to reverse that, now we can allow machine ideation followed by human fabrication. So I think that can bring a new light on how architecture can be done in the future. And also, just to reiterate some fears that some people may have that's replacing our jobs. So sometimes I would like to give an example and say, yeah, for one example, if 20 architects can be reduced to just 2 architects, potentially 2 stonemasons can be increased to 20. One of many ways. And beyond that, I've also worked with some brands in order to see how we can use AI design to also fulfill the fabrication process and see how products can be derived from it. So I work with MADI. Actually, he's in Venice as well. He has a showroom that he's just opening, and he's an Italian handcrafted furniture company. So we're working on a set of chairs that are designed by AI while curated by human and also fabricated by hand. And also working with Sprayground, a fashion brand that does luggages. If you guys are familiar, it's the one with the shark mouth in the back. So he came to me to see what we can design in terms of, how to bring some new ideas with AI. And so we have a series of designs that utilizes this technology and bring some futurism to it as well. So finally, architecture. Basically, what I'm trying to do right now is trying to rationalize and understand the irrational forms that is shown to me. And through what I have as my specialization of understanding geometry and parametricization and working with algorithms, I produce, that was the last slide. So I produce a lot of ways to try to actually capture the essence, the mathematics behind these structures and actually rationalize it into 3D. So right now, that's a linear method of human interpretation. But I also would like to say that there's a potential, it's not going to be like this forever when large language model and things like that really take a place. I think a lot of these things will start to become more AI oriented and automatic. So just to end it all, I just literally rushed from another panel that I had, as well as a presentation of my works, working with both the stonemason the sculpture, as well as some of my works printed in formats for you guys to see. So whoever's interested, go to the Palazzo Albrizzi as well. You will see a AI created hand carved 3D column. Right, I think that ends for me. Thank you.
So we're quite tight on time. I would love to get Ross to give a comment at the end, so hopefully we can squeeze that in. In the meantime, we do have Nicolo Casas, who has been, he's one of these guys who's stuck in regular, where it is, the place where the water is, you know, now. And he can't hear me. He's on Zoom. We have to switch off our video, our audio this side. Nicolo.
Okay, let me know if, first of all, if you can hear me, and then I'll try to share my screen.
Yeah, we can hear you.
Okay. Can you see my screen?
Yes, we see it on Zoom.
Okay, perfect. Perfect. Thank you very much. And is it on the screen as well?
Yeah, we're just seeing on the venue if everyone can see your screen.
Okay. Yeah, can you hear me? Can you see the screen? Yeah.
Yeah.
Okay. First of all, Neil, thank you very much for having me today, and thanks for the University of Venice for having me. It's always a great pleasure to share my work with students and colleagues, and I apologize for not being in Venice, but you know everything about what is happening now in Emilia-Romagna. It was impossible for me to be in Venice today. So, but I'm gonna start. I'm gonna briefly show, introduce a little bit about my work. I'm an architect. I'm a multidisciplinary creative, working in different fields, from design to architecture to couture to fashion tech. This image beautifully represents my work because it's a picture, a black and white picture of a dress, a 3D printed dress that I made in collaboration with Aris van Herpen a few years ago. But at the same time, it's I really love the coexistence, the bending, the togetherness between the pattern, the model, the dress, the 3D printed pattern of the dress, and the space around the body. I think that this image captured my work, and I had a great opportunity to, first of all, just briefly to collaborate with amazing women in my life, with Anouk Wiprex in fashion tech, with Iris van Herpen in haute couture, with Beth Cartier in artificial intelligence. It's always really important to stress out the importance of women today in technology, innovation, art, and creativity. I also had the great chance in my life to be part of 3 important revolutions in our fields. The first one was the digital revolution. At the moment, especially, we started using digital tools with big data. The second one was the moment we started fabricating in a digital way. And the 3D printing was the main tool I had the opportunity to employ, to investigate. And today is the artificial intelligence revolution in design, and really soon it's going to be also in fabrication as well. So it's I had those are 3 images. The first one is about the investigation on big data, fractal, complex geometries, the beginning of my design career. One of the dresses that I made with Iris van Herpen, and one of the last images I created with artificial intelligence. So you can see a sort of continuity and consistency between 3 very different moments in my professional activity and my design research. 2 are fabricated, so they're real. The third one is an image. But today I'm going to talk about artificial intelligence. I started using it mostly with Midjourney in July 2022. So it's not even 1 year that I'm using it, and I'm not an expert, as I'm not a really great expert in digital tools, in digital fabrication. You know, my work, I'm a creative. I like to play with the tools. I like to investigate. I like to combine different fields, different ideas, different tropes. And the idea of combination and coexistence is the same, basically the same idea I try to use every time I'm investigating a tool or doing a design project. Those are some of the first, as Neil employs suggestion, artificial intelligence suggestions. I really love the term, architectural suggestion, that I created with Midjourney. My idea is always the same, investigating this coexistence between complex shape and minimal shapes, between the natural and the architectural, between a geometric shape and an organic shape, between geometric forms and organic, between the body and the space between body and natural. And we're going to see that in the future. And you see how in less than 1 year, the tool artificial intelligence evolved from something that was almost as a painting, a real not determinate suggestion, in something that started acquiring architectural understanding, the space understanding, the light and shadows understanding, and volume understanding as well. And in the moment the tool evolved, also the possibility to do to employ it in a really interesting way in terms of design investigation evolved. Again, the idea is always the same. The prompt that I use are very often similar. It's about creating this tension, this coexistence between organic and geometric, between a sort of contradictory sort of states. Visual, aesthetic, and formal states. What is truly important is having developing a lexicon, because as we all know, it's Midjourney and artificial intelligence are based today as main and as main tool as text to image or image to image combination, production, and generation of suggestions. So what is really important, I think, today for architects or for designers is to develop their own lexicon, their own narrative, their own sort of ideal word that should be consistent at different scales and in different situations. And again, the tool evolved in less than 1 year. It's more or less 8 months now, and as you see, become more and more realistic. In a certain way, lost some of the again the pictorial of the undeterminate that I really loved at the beginning, but it became a really important tool for, especially for architecture, to design and to create architecture, a catalog of architectural situation, of architectural suggestion that could be shared with possible clients, with possible build interest in building, and also especially to convey your architectural idea, your architectural concept. That again, in my case, is always about this tension and coexistence between organic, complex, and linear geometric elements. It's not about just again designing a building. It's really about creating a new form of coexistence between what you have in mind and what how their artificial intelligence interpret your prompt, so your words, your idea, and then create a sort of unexpectedness that then can enrich in some way both your architectural lexicon, and in the same time can also enrich what the artificial intelligence is capable of creating. You learn from by creating, by designing, and the artificial intelligence create by designing. So if you see the little by little why artificial intelligence as a tool evolved, I also evolved my language, trying to sort of break or create a more complex relation between, again, the geometric and the organic, between the nature and the building as a space. Try to create something that was more, in a sort of way, damaged, less preserved in the duality of elements between, again, the nature and the building. The building started little by little fragmented, sort of breaking, always maintaining the same consistency in terms of lexicon and in terms of narrative. And this was especially possible because actually artificial intelligence and the Midjourney evolved and gave me the possibility to, let's say, be trustful, also experiment a more complex architectural situation. And this is some of my current work and current investigation, when again this relation and this tension between the geometric become more sophisticated. It becomes tiling, it becomes a pattern, and it becomes more fragmented, more let's say less preserved in the duality. At the same time, I think that artificial intelligence is a fantastic tool for multidisciplinary investigation. And as I said at the beginning, I've been working in fashion tech, haute couture design, automotive design, and so on. But I always loved photography, black and white photography. I'm an art passionate, and I will also love especially street art and collage. So I had the possibility, thanks to artificial intelligence, to, let's say, transform something that was, a passion in something that was a little bit more professional, let's say. And then this idea of, again, tension and coexistence and bending between the natural and the organic, the geometric, became a sort of coexistence that I got through collage, digital collage, artificial intelligence collage, because the images that you see here, both the body and the pattern as well are artificial, are generated with artificial intelligence. So I started creating a series of art portraits and investigating the possibility to, again, use and play with artificial intelligence in an art field, in the digital field, in the NFT world. So again, another digital space, the metaverse, and I had the possibility to expose to show my work in New York, here on the left, in Paris, on the right, in Brussels, and so on. Because actually there is a lot of interest both in NFTs, of course, but in the impact of artificial intelligence into art. And so one of the things that that I truly believe also the school should investigate is really about creating a space of meeting, a space of dialogue that employ artificial intelligence as a way to foster multidisciplinary dialogues and multidisciplinary research investigation. I really think that being a quick tool, an easy tool, a tool that is based on lexicon and everybody has its own lexicon, you can really foster multidisciplinary encounter and disciplines. Having, again, using it for fashion and haute couture, those are some of my experimentation of using artificial intelligence in fashion. So at the scale of the body instead of the scale of the architecture, always the same relation. In this case, I don't have the geometric, it's the body and the complexity of the dress that are plain and coexisting in one unique situation or piece of art, let's say. Of course, we can use it for investigation in design, in object design, and in different scales, and again in different fields. I just want to conclude now by showing you the last thing that I've been developing that showed a great that every time we have an update in the tool. In this case, again, I use Midjourney, mostly use Midjourney. You have the possibility to create something that is more serious in terms of the proposal, but also to investigate again different situation, different in the last images that I'm going to show you now. What I've been investigating is the coexistence between let's say two architectural bodies, between two volumes that interplay. So what you see here is a strange crumbled architectural building. Was generated by an AI investigating the idea of volumes, in my case, two volumes being combined, coexisting in one in one coherent building. And again, it becomes more and more serious as possible proposal. And some of the last images that I made were truly mistaken in recent time for something that was built, that they really asked me where those buildings were. And I think, you know, but what is really important again is that to develop your narrative, your professional, artistic, creative, and architectural lexicon, trying to be consistent and try to design and to create spaces, dresses, objects that can be trustful and that could be built. I'm gonna leave you with this last image that actually was a really hectic moment with one of the dresses that I designed with Iris Van Herpen that was delivered at the catwalk really at the last moment. And, you know, all the team started stitching the 4 panels of the dress just a few minutes before the catwalk. But I really love this image because it shows how you can have a really unexpected coexistence situation, and an unexpected moment of between the human and the digital. In this case, it's a 3D printed digital dress that is assembled by using traditional stitching techniques, and with the human and the hands working and finishing something that was created by a machine. And this was a revolution a few years ago in terms of this relation, let's say overlapped relation between the craftsmanship, the human craftsmanship and the human knowledge and the digital, that I think today is going to find a completely new definition in the relation between us and artificial intelligence. Thank you.
Hello, thank you, Nicolo. I hope you can hear me and see me.
Yeah, I'm just trying to stop sharing my screen so that
I can help you. Yeah.
Yeah. Hello. I'm Fabio D'Agnano. It was an incredible day today. Fantastic content, and I have the inglorious role to stop this, even if I could look at it for hours and listen to your stories for hours. Unfortunately, we have to end this session now, and I hope there will be a follow-up about it. And the university actually has closed 20 minutes ago, so it may seem unpolite and brutal, but this is the only thing I can do. Frankly, this doesn't mean that I mean, it was exceptional. It was outstanding. And thank you for Neil and Arturo to organize this along with me and to make it possible. And thank you to all the other speakers to share their experiences. And well, that's it from my side. If you want to briefly close, Neil or Arturo.
Can we, one small thing, Fabio, we have a very distinguished guest this evening, Ross Lovegrove, who is one of my favorite designers of all time. His flight was delayed, and he's here with us. And I would just want to invite Ross, who comes up with wonderful pearls of wisdom, and he was part of our roundtable discussion, to offer, maybe come up and just offer a few reflections on what you've seen and what you heard, and even maybe to say a few words about your experiences in Milan. But Ross, it's fantastic to see you.
Again, Ross is God on earth. It's very, it's fantastic to see him here. I'm really sorry, Ross. I have to ask you to be very, very quick. But thank you for being here. It's fantastic. Sorry to ask you that.
time, it's become so limited, so repetitive. You know, if I go to the salon now, I just party. I don't look at anything. Yeah, because it needs a kind of revolution, and creativity is a form of destruction, because what it does is it often eliminates what comes before. Creativity is a destructive force, but I mean that really positively, because we need to kind of swipe away and replace without any fear. You know, I go from the analog to the digital. I was working in the 20th century analog way. You know, I moved into the 21st century. I dropped everything. I bought all the hardware and the software. I joined the club. I been as digital as it gets from day one. I had the first computer in London. And we used to play Pac-Man, and then I'd be designing a pen for Louis Vuitton. So it was like, it was a really incredible transition, analog, digital, but now AI. And with that, and I want to follow that. So I remember years ago, because you're all architects, being at the Venice Biennale, and there was the American Pavilion was curated by Hani Rashid and Greg Lynn. Greg's a really good friend of mine. And it blew my mind. It was all about process. There was no result. It's all process-led. And it was like a wonderland. I mean, that's a long time ago now. And I went to dinner with David Chipperfield, and he said it was the worst rubbish he's ever seen. Of course, David would say that because he's on another path. So that blew my mind. And so in my whole life, I have, certainly in the last, say, 20 years, I've aligned myself with architects, because you're so well educated. You convey ideas in the most sophisticated way, even if you don't get results. You know, so what are we doing? What I love about AI is that there's a lot of work that we do as designers that never gets a result, never gets made. There you are pushing boundaries like hell. And there are often, I practice something called success from failure, which means if it's not going as I want it to fail, because I don't want to make something which is below my intellectual capability. So you're only as good as your client. So, you know, you guys, a lot of it's research, and maybe it never reaches this sort of conclusion. And what interests me is how to harness this incredible work that you all do and turn it into reality. So when Roland was showing stuff, it blew my mind, because I'm really interested in the 3D printing methods, stuff, Formula One, we're pushing, we're trying. And, you know, there are discussions, I was just in Dubai at the Museum of the Future, that people were asking about high precision, and I'm saying, well, that's fine, but maybe that's not what it's about. So when I see what you do with 3D printing at the moment, I'm thinking, gosh, the rawness is acceptable. And then I'm with an astronaut talking last night at the Triennale about space architecture, and I'm thinking, wow, how do we take the work that you guys are doing and kind of converge and coagulate that into a whole new breathless way of dealing with irregularity and biomorphism, and, you know, break free from this containment. And the trouble you've got is that you've got particular methodology in place which stultifies all of that potential. If you take the car industry, and if we all got together in this room and did a car, boy, watch out. Yeah, and I've been out to SpaceX, I've been looking at how they 3D print their parts and all that sort of stuff. The problem with like the car world is that it's part of a supply chain, and you can't break that. And it's about numbers. You've got to produce X number of supply. So you're never going to get rid of that, you know, unless you come with a fresh new way of doing it. So I'm interested in, like, and I've been in meetings with clients where the client has been so angry, not with me, but he's moved everything off the desk, the laptop, the coffee, just pushed it all onto the floor. Not with me because of his staff, because they don't step up to the plate, to my intellect. Do you understand me? And, you know, this is how you need to talk to clients. You need clients that really want to push those boundaries. You know, I got no work to show. I'm leaning forward. And, you know, I don't have a studio anymore. I've got rid of the studio. And I prefer to collaborate with the great minds of our time. That's what I want to do. So that's what we're doing. We have a massive studio because we just collaborate worldwide. And, you know, just had a conversation with Tim in Milan. We were not part of it, but we quite serious conversation. So it's not about me. It's now about it. So AI it's phenomenal, and you cannot have a fear of it, because why? Because human intelligence is compromised and it's corrupted and it's limited, as are all the industries today. That's why everything looks so banal and repetitive, because they're working with a kind of condition that needs to be radically transformed if we're going to kind of transform. Sounds big, but like civilization, because we got big issues. And it's lovely what I see, that you've got to feed into AI things which will eradicate the insanity of humanity and the greed and all that crap. You've got to put in there logic. So lightness, dematerialization, how you move things around the planet, how you build it, what you build it out of, the birth, life, death of that building, time. Are we building for 1,000 years or a lifetime? I mean, it's really interesting. And the trouble with humans is they don't really think that way. But AI, unemotionally, will deliver the logic which will allow our resources to go further. Yeah, because they need to. And things will look really beautiful for it. I'm knackered. I've been traveling. I haven't been to bed. I don't eat. I got a 7 a.m. from Milan tomorrow. So I don't want to go on too long, and I know he's probably thinking he's talking too much. But I love you guys, and you are a hope.
Thank you, Ross. That was some real pearls of wisdom there. It was a perfect way to end a perfect afternoon, early evening. Can I just repeat my thanks to those who organized this? Fabio, especially there in the UK. I have to mention the Digital Futures team that is working so hard behind this. And if you're ever interested in finding out more about AI tutorials and so on, there is a library, a YouTube library, Digital Futures YouTube library, where we put everything. It's there for free for everyone around the world. And lastly, I want to thank Arturo for being the kind of the catalyst that brought this all together. And what an incredible event. And I hopefully we'll be able to do this again in the future, because this is an amazing place to hold this, the Aula Tafuri, in an incredible school with some of the most incredible speakers out there. What a fantastic afternoon. Thank you so much for the contributors, and thank you for coming along, the audience. Thank you. Thank you.